Okay,
Right.
recording is started, and you're still sharing the screen. That's good.
Okay.
All right, so welcome everyone to Ontology Summit 2020. Today is Wednesday, April 8th, 2020, and I'm very pleased to introduce Binil Snarley, who heads the Digital Manufacturing Group at NC State, and he's the James T. Ryan Professor. And so we're very excited to hear his work on the Open Knowledge Network in product design and manufacturing. Binil?
All right. Thank you, Ken. Thank you for having me here in this virtual summit. I'm told that this has always been a virtual summit, but I think all of us are getting used to getting in and out of Zoom meetings. So certainly that's what I've been experiencing the last 2 weeks. This work has been really in the last 6 months, maybe about a year or so, and then when NSF supported the CAXL program, myself and NYU, Daniel Penozo, which I will also integrate into this talk, worked together along with the University of Oklahoma to try to at least see what can we do in this space. And I know this is a space that has been built on in at least multiple decades of work. And our interest sort of came in from an alternate dimension, and then, hey, maybe we can integrate with the knowledge graphs part of it. So I wanted to share not only just the use cases, but also what we are trying to do now, and hopefully that will inspire the discussion in the later half of this talk. Over the probably last 2 years, I've been traveling, I've been meeting with a lot of the manufacturers across, and many of us probably know this. 70% of all US manufacturing is performed by US small businesses, right? So we're not talking of like a 500 employee company, we're talking of 30 employees, 40 employees. And a lot of them, I'm talking to all these companies along with my students, many of these small manufacturers are very razor thin margins, around 5 to 7%. Some of it that is spent in, of course, in market development, capital intensive projects right there, or training employees. But that's a very thin margin that, in this age crisis, it's a very destabilizing scenario. Some of it are non-value added tasks. So one of them is like they're trying to project their capabilities to other clients. Many of them spend Google ad credits, Facebook credits, go to trade shows, and most of them rely on human networks and who they know and repeat businesses. And it's extremely hard to move from one supply chain to another. So if I had a company that is doing automotive supply chain, if they wanted to ever get to the medical device, it's an extremely hard battle trying to get into that space. And so most of them rely on these listing directories, pay thousands and thousands of dollars to be listed in there, pay ad credits just to project their capabilities or what they can do. And of course, a lot of phone calls that clients come, hey, can you do this for me? Can you laser cut 2-inch thick steel? And say, no, we can't do that. And so a lot of that is just wasted time and effort. Quoting is also a process. If you look at the other side, engineers graduating out of colleges and universities, they have a completely different mindset in how they interface and talk to manufacturers. They say if you're in a small company, an entrepreneur or a startup company, they prefer to have all their CAD/CAM software, and companies where they digital design their products. They're completely different modes of communication, and many of them probably don't have all of the knowledge necessary to do this. So finding the right manufacturer is important. The quotations from manufacturers take anywhere from 1 to 2 weeks. Sure, you have platforms now like Exometry and Fictive and Plethora that sort of enable cut that gap down. But a lot of that is manufacturing marketplaces that are driven by information asymmetry that is hiding identities on either side, which is not really a sustainable process. And so that's one use case. And then I've always say, why is it product design still a domain that is to be specified or used by expert engineers who have decades of experience in using a particular CAD software like SolidWorks or Autodesk Fusion? But can a 7-year-old engage in product design, right? And so this kid is drawing his favorite fire truck based on what he has seen in the past in cartoons or pictures here and there, but his version of what that fire truck would be. So can a child with smart interfaces be able to design these objects based on what his version of his inspiration for that is? And today, I mean, it's probably, now you can probably draw it, but there is no way that he's going to be able to transfer that over to a 3D print in a cheap, fairly cheap. You spend hours and hours, and yes, you can do that in there. So if I were to take this simple example and take it a step further, that if the child had a smart interface that could be either voice enabled, that was detecting the kinds of pictures that you were drawing, and if there were algorithms that could assist that child to design a fully functional toy. Now, the child probably does not know assembly constraints or mating constraints, probably doesn't care if it has 6 tires, maybe he wants 12 tires. But the point is that the systems know that they're trying to draw, and he's trying to draw a fire truck, and automatically on the right-hand side or somewhere comes related components that you could drag and drop based on what the child is drawing. Now, today, there are customized interfaces that do it for a very specific category of products, but not something that is very generic. But if algorithms could assist that child to design a fully functional toy by assisting all the possible variations of fire trucks that are out there in repositories, in public repositories, in designs that are shared by hobbyists, by just amateurs or even professionals, and if it could synthesize exactly the kinds of related components or even similar components to what a child may have drawn, and then, hey, I don't like that ladder, but I really like this ladder, so let me drag and drop that. That could sort of enable the child to do it. Now, your drawing is one thing, but how do you actually, let's assume that now the child is really, really curious of wanting to toy build. And let's say the parent is probably not going to spend the time to do it into 3D, and certainly it requires expertise to do that. But if you could reconstruct that with all the components that are in place, that you reconstruct now a fully 3D printable toy, and if you could then put it onto a marketplace that you could then build it, and then eventually the designs are now sent over to distributed factories across the country or even locally within wherever the child is or the parent is, and then have that toy back in there. Of course, the toy is probably going to gain interest for the child in 2 weeks, and then after that, for those of you who have kids, probably in 2 weeks later, that toy is gone, right? But the point is that this is heavy personalization that is driving the products. And today, it's kind of possible to do with myriad technology, but extremely expensive. That fire truck will probably cost $1,000 or more, which is not possible. And now that we see the COVID-19 crisis, and I thought this was a very futuristic, that there's no way that toys could be a motivating example. But we are now seeing with the COVID-19 crisis is that everybody is trying to do distributed production. Where can I 3D print my PPEs or masks, or can I contribute this design, but then where can I make it? It's not easy to sort of gather. If you have the resources and the network connections, you can get that done, but not typically easy to do for a generic population. Forget toys, but then there's examples of personalized medical implants. There's part catalogs in the DoD DLA that is waiting to be found, manufacturing services who could find this. There are people who are spending their time trying to find sources who could make these parts. Personalized medical implants is another good example of how you just need a limited quantity of one or vintage automobile components, right? So in all these cases, really, they're often on demand. You can see that with the PPE production in this COVID-19 crisis, we need very limited quantities, especially if you're talking of personalized medical implants or automotive components, and specific source requirements and restrictions. And so how would you find manufacturers who are capable of delivering this? So why is it not possible today? Since personalization is expensive, right? Expensive only because you require a lot of human labor and work to be doing that. But then who can make what, when, and how much? It's not an easy source. You would have to go through layers of information sources to find and contact and delete information retrieval back again. It's not an easy as an instant go to an Amazon-like thing and they're surprised of what you're not going to find that easily. Sharing of data is also a concern, particularly intellectual property, and how do you analyze data when, especially when the data may be protected or may be private. Trust and reputation of these service providers could also be an issue. If you see the problems and challenges faced by 3D Hubs, which was a marketplace that enabled also 3D printers to come in, a big challenge for the 3D Hubs was they had all these disparate manufacturers or home garages with their own little 3D printers coming onto the platform, but most of them, 80% that we have analyzed, is just completely worthless pieces of not actual production or not actually capable of being produced. So how do you trust these service providers and be able to rapidly compute that to enable these connection between clients and services? All right. So if I only wanted to focus on two pieces of technology in there, I'll just focus on two aspects that I wanted to focus for this talk. First is algorithms must be able to search through hundreds of related and similar parts for the child to construct. Right, so that's a search problem. Search across 3D model shapes, not search across images, but searching or using an image or using an existing 3D model as a template and finding related parts, either as a functional parts or similar parts that would come in. And now finding fabrication service providers, not in the context of 3D printing, but in the context of CNC machining, laser cutting, laser drilling, all the different myriad of manufacturing services that that would be involved. So how do you find these fabrication service providers over and beyond what Google or a normal Google search would do? Right, so I'll talk about the search space and the work that we have done so far. 3D product model search, so using images in 3D product to find other related parts, models, and assemblies. So if you go to GrabCAD, grabcad.com, thingiverse.com, there is hundreds of millions of individual parts, and probably at least, I think GrabCAD has told me that there's about 8 million assemblies or so that various people have uploaded over pieces of time. GrabCAD, a lot of it is hobbies, but a lot of it are professional hobbies where you really know CAD because you can see the myriad of competence there. And one of the big challenges, if you want to tag or find anything in there, now that it has grown so much, that is not really easy to find anything. If the user has not tagged it properly, you will not find it. Second, I've seen several instances where the users are simply tagging it with content that absolutely has no relation and simply trying to drive a search term so that their page would come up even when there is no relationship between the tag and what they have produced. And so we have talked to GrabCAD, and a lot of the users would really like some tools. Hey, I really like that CNC machine, but I also really like the components that they have in there. What other models in here could I have that look exactly like that CNC kind of model shape? Or I'm really interested in that cover and other models like they have in that cover. And a lot of the users have told me, GrabCAD as a keys tool said that there is interest in that space of being able to do them. Right now, there's absolutely no way to do it. You just go through pages and pages of content before you find something useful. Same thing with Autodesk Fusion Gallery. There is 3D Content Central. And if you want to look at a particular link of a 3D model, I'm not sure what I linked, but I think this was an AirPod assembly. Yeah. And you will see how they have tagged it with certain pieces of information. So what we have done is we haven't taken the entire, which is impossible to do. We just took a subset of parts that they had. I think it was over 3,000 assemblies. And then what we did was we processed all of those 3,000 assemblies and individually broken them down into parts, maintained the functional relationship between the assembly and sub-assemblies. And just 3,000 assemblies broke down into 110,000 parts. More than a terabyte of content, meaning that we just share it in STL, STEP, all the different versions. There are some categories, there are lots and lots of bolts, lots and lots of washers, many of them. And so we processed all of that and saved this in a repository that we typically try to share. My collaborator on simultaneously, when we were doing this, my collaborator was able to get access to the Onshape database. And Onshape has this feature where public users can use their software for free, but then you can model this object. But the only condition is that that model will be now publicly available. So Onshape gave access to Danny Panoz at NYU. And he is able to download more than 10 terabytes, more than 1 or 2 million 3D CAD, individual CAD parts. Now, a lot of those parts are amateurish, but there are a lot of parts that are very useful. You can see his paper if you're interested, and he's actually also shared the entire data sets if you have the capability to download more than 10 terabytes of information. So now, problem here is in all this space, so how do I search? A lot of this is a similar gears, little blocks, everything in there. And so categorizing them, you can categorize them for standard product parts like gears or things of that nature, but there are certain parts that you just cannot put into any particular category. And so what we just thought is, okay, we'll have to, if each of these individual parts were a node on a graph, surely there are lots of similar parts, and we'll probably have to link them together or bring them together so that we're not searching through multiple similar parts. So what we did is we sort of classified, at least hand classified 1,200 models out of this entire 110,000, just 1,200 models. As an academia, we have fortunately to get students to help us in this category. Also synthetically generated some of this data. So we just basically trained a deep neural, a geometric deep learning algorithm to at least recognize these shapes. So prismatic shapes, gears, washers, springs, only 10 categories. We didn't do anything fancy, just 10 standard. Some of them are standard categories. The only flexible categories is prismatic, which could have any generic shape, but everything else is your standard product categories. Maybe cylindrical also has variations in there. So we did this, and we trained a geometric deep learning. We used a convolutional neural network, but not your standard convolutional neural network. This is something that is built on images and not your voxelized images. Because voxel images, if you were to use that on typical CNN, you lose all of the resolution that is typically needed. For example, that gear assembly, a gear part in there, you would lose all that resolution in the teeth, which is probably the most critical feature for that part. So we simply go through layers of this network. At the end output, and we have the dissertation for the student that is published, so you can have the details there. But for every model that we have in our data set, we then end up getting a numerical signature that would describe this particular part, right? And then we use that numerical. So now it becomes an embedding for this 3D model shape, driven through images, and then you get a numerical vector that describes that shape. And so we did this for parts, and to find, okay, how many similar parts do we have? To compare some of the older methods, one of the older methods is spherical shape harmonics method. We tested that algorithm across our data set. You can see this particular comment, I don't even know what to call this, but certainly it has male and feature parts here, and it's certainly part of a bigger assembly. And think, hey, can we find similar parts that look like this? The SPH algorithm, if you're aware of it, it's not perfect, it's not great, but still really good. And it was able to found itself, which was what was a check for, can it find itself? But yeah, a lot of the other parts, so I have no idea why a cylindrical disk would be looking at this. Probably the only thing is that disk there, and then there's that circular shape that may have to retrieve this. But amazingly, the geometric signature was able to find very similar parts. And then, for example, here, you will see how it found this a female component, typical computer component there. And then so it also found this particular thing that it has the male version of that. And also related components that you can see. And so somehow the system came up with that function that sort of converts this to a numerical signature, and then we're simply able to gather related components. And then we were able to, although we have trained it only for 1,200, not even actually less than 1,200, some of those tests. And then we were able to then translate them across 110,000 models. So then what we did is I took a subset and I just plotted this whole, plotted versions of it. I think this particular is only about 9,000 nodes in here. And then you can look at this. There's a live version of this. If you have a good GPU, good enough GPU, then you can sort of visualize this. But if I were to focus on one particular node, what you're able to do then is take this graph here, take this object here, the 3D shape of this object, analyze it across 110,000. And I found similar shapes. So I'd have a plate with 2 holes, but then I'd also found, okay, there's a plate with 4 holes. But then also found, and there's too many plates with 4 holes. But then there is 2 models that had plate with 3 holes, which is actually circular holes, where these are square holes. But it did the best it could to find similar models. But now if I take this a step further, now that model is related to this particular object, which had 4 holes, but there is this tiny slot there that was slightly different. Each of these edges here represents the similarity score of how there's a numerical vector for one object, a numerical vector, a cosine distance between them tells you how similar these objects are, scaled from 0 to 1. And then if I go to grid this further, then it goes from here, start from here, it goes there, it finds the related component, but then this thing is now related to other components in there. And you can do this for a lot of the parts that you just keep growing, and then you end up getting this. And so right now, although all we have is just similar relationships. So what this thing really helps us now is across our 2 million to 3 million parts, we can now find all similar parts and sort of even remove very similar looking parts. So all the bolts, put it into one single bolt, or all the plates, put it into all plates, and sort of clean out and make our graph a little bit cleaner. And we can also add a layer of functionality where, okay, where was this particular part and how is it related to, and which assembly did it actually come from, and what is that assembly? Is that an automotive assembly? Is that an aircraft? Is that what exactly is it? So you can build now functional relationships from there. And so a lot of this is, again, 3D shapes, right? We don't have text in there. And so now we are going through this process of sort of augmenting the 3D shapes with text-based information. So we are going through this process of getting, again, students and paid students to go and annotate a subset of our data sets so that, hey, is this a standard part? Is it a non-standard part? Is it, how would you describe this part? Okay, so I would take that this is a thin-walled component that with lots of bolts and features, where I could then have a student here. You can see that you can even describe if there's a material category, assign it. If you think you know what the material category is, put one there. Is it mass production, short production, standard, high? What manufacturing process would you use it, and what other process that you know are aware of? You also have a Wikipedia link if it is a standard part, or if it's an easily identified part. If you can find a Wikipedia link for it, add that. And then also feature level descriptions. Tell the computer, hey, that's a bolt, this is a fillet, that's a U shape, that's a thin wall. And so we give students the ability to tag 3 of those features and write short descriptions for it. And so we're going to, we did this process, and right now we are up to about 5,000 models that have been human annotated. Hopefully will then serve to automatically tag a lot of the entire 3D models that we have. In there. So that's our work in that space very quickly. I'll be happy to take questions later on in that space. Now, the other part is finding capable manufacturers. We're always looking at how do you find capable manufacturers. This is just a cartoon figure trying to say, hey, give me custom machining services for peak parts who have a track record of medical device fabrication. You can't. You put that into Google, you won't find a search for that. Basically, what you're going to find is either explanation of peak, or something not even related. You would have to go through pages to find this information. But is there a way in which you could query a graph and then find me custom machining service for peak parts in the New York area who has a track record of medical device fabrication? Okay, here's a list of suppliers, and I think we have joked about Siri, but some sort of a conversational agent that could then assist this human product designer to sort of rapidly iterate towards a service, like a material that could be made out of this and also finding services who could custom machine or custom make these limited quantity of these things. But you can't do this today. First, you have to have a joint embedding between 3D model and text data. Whole entity that I previously described was just an embedding for just 3D models, right? But really, when we as human brains, we think of stuff, when we look at a car, we look at objects, there's actually superimposed information of text as well as 3D shapes to it, which is not how the algorithms as of today work. So how do we jointly embed both text data and model information together? We do not have a named entity recognition for our domain-specific knowledge. And what I want to show is, hey, we don't even have an updated list of manufacturing service capabilities across the USA. So we then did, okay, let's address this red problem here. And so we web crawled through more than 22,000 small job manufacturers across the USA. We have gone to a depth level of 2 and gathered all the text information that's on the website of their company. A lot of them had very good websites. A lot of them did not have a lot too good. But then we gathered all of the text, indexed the text, and we in between this, there's arrow between now before you get to graph. We actually have a small named it a neural network that would then classify whatever text that is already available in there. Not as perfect as we would like it, but we did what we could. And then we just stored that in a data. So essentially what you're getting here is we will have a machining, which is a capability of a company name. Both the numbers that you see here is the URI for the specific terms in Wikidata. And then we have obviously attributes for each of these company name, which is then a subclass of business, which is, so we're trying to link whatever information we collected from this website to link it to what is there in Wikidata, so that we can sort of link it back to what already exists, so that we can connect between graphs eventually. Right, so this is all we have, and so we connected. This is just a visualization of how much each of these little white dots is a specific manufacturing process. It could be thermoforming, it could be CNC machining. How much time I have? Keep time. I'll just new share. I'll just quickly show. Let me see. Yeah, so let's see if we can see a stop share. To share. Oh, I can't share now. Oh man, bad. I can't share. Can somehow something host disabled participant screen sharing? It's weird. Can you share me back, or rather, I can't share my screen now.
You're shared back. You
Okay.
should be able to do it.
Okay. Right. So you can see this. This is just a visualization on Kumu, where let's say, so this is thermoforming here, but then it links back to all the companies that provide thermoforming in their relationship here. As I said, is just provides these capability. If I were to go one up the graph, then I can now say, okay, let me take some time to update in there. Okay, so then here, yeah, you can see, so what you will see here is now thermoforming has these companies also provide forming as an example. So you could grow and build that graph as needed. So, and so I know what we are hoping to do then is really keep growing this. 22,000 is just a small subset of what we have. We have a portal, or intend to make it a little bit more professional portal. I have a prototype built where you can now start searching for specific service capabilities over and beyond what Google could provide. And then a little bit of a geographic summary where these potential services included. You can have a little brief summary of what they have and what they have done, a website connection to it. But it's still not perfect. A lot of the manufacturers don't have really good websites. Some of the content is Adobe Flash content or image content. And a good example is, I tell these to manufacturers, you guys are ISO certified, you have this AISI, and do you know exactly how you put that on your company? You put that as an image. And Google, when they index, you're never going to find you that unless a human user is going to look at your website. Google would never know that you are an AISI certified or ISO certifications of particular quality. So a lot of them don't realize that. And I'm wondering, and this is probably an open question for the group here, is it worthwhile that as a community, we go and contact all of these manufacturing service providers? And if you go back, some of these manufacturers, not all, but probably 10 or 25% have added the Facebook Open Graph, the Twitter Graph content as a meta header categories on their website itself. And some have added the Google schema. A lot of this is repeated information through. And so can we get manufacturers to embed manufacturing specific vocabulary that sort of relates to what they already have on their site? But beyond that, add more capability information that we could then, and it's distributed because this content would be on the websites of the company. They would have a recommendation, keep it updated. So then automatic crawlers, whether it be Google or whether it be any other researchers or any other tools, would then go back. And so the current relevant capabilities of what they provide, what materials they have on stock, or rather what have they worked with, any information that they would publicly reveal, not private information, but publicly reveal, so that when a company says these are the services they provide, they're CNC machining, that they don't use some other term, that all of those words are now tagged back to specific URIs that then enables us to link across multiple manufacturers. I've talked to a lot of at least 10 manufacturers, and they're all interested. It's a free tool. Why won't they want to do it? We've said that you can release an online tool that you can automatically tag your own website, and then you would create a JSON LD script that they could then simply add it to the meta header. And 10 people were ready to use it, but 10 people alone is not going to suffice. We'll probably have to classify this across hundreds or thousands even, actually. And so next, and also we have, not just the websites, we started to also tag some of the content in research abstracts, as well as manufacturing textbooks. And we have nowhere near to sort of completing this entire circle. We're still stuck in this named entity resolution because we do not have, none of the NLP models that are out there are going to understand any of the manufacturing text and content. And so we have then started at least this process of at least looking at all of the index keywords and then having us categorize each of these words that you have on the left-hand side and then categorize that on the right-hand side in 10 categories or 12 categories that we thought of. But there could be more, but we thought we'll get started somewhere where hopefully would tag, manually classify these words. It's a fairly quick process. It wouldn't take it probably just a week's worth of work. And then try to see if we can automatically tag related concepts, find concepts that are closer to each other, and then hopefully then drive a model that could then use us to connect between content that's available in a blog or a tech article or a research abstract, and then link it back to an existing the linked data sets in DBpedia or Wikidata, and then hopefully then build on the knowledge in there. And so this requires community help. I know there's a lot of work in the knowledge graphs. There's a lot of work in ontology. And so we are looking for, at least in the forum here, we're looking for guidance as to, is this the right way to do it? We have a shot at doing this. There's a lot of existing work that is going also in the private enterprise, the private data sitting in the enterprise, and many of these companies, all we're working with is public data. How much of it is a challenge in private enterprise data in trying to connect networks? For example, Boeing and all these other companies that have lots of 3D models, they have millions of models spread across. A big challenge for them is a lot of the data, they do have 3D models, but a lot of the data is still text and drawings and engineering specification documents. And going and analyzing all of that is a significant exercise. But knowledge reusability is still one of the big data sharing also is one of the big opportunities that manufacturers could utilize. So I think the future of manufacturing is really collaborative AI for personalization of products, automated service marketplaces that can connect, that can reduce layers of inefficiency between clients and service providers, and then automated production that is a local distributed production, so that whether it be medical implants, whether it be replacement parts, that you're really getting a community and a local region to drive the production of that thing, again, all digitally. A lot of this work, while this Connect work was not in the open knowledge graph, a lot of the work still came from the NSF Cyber Manufacturing and the DMDI Connected Machines program, and also thank a lot of the students that we have here. Thank you. Thank you for your attention.
Thank you. So now let's move to questions. Todd, you have your hand up?
Yes, I do.
Yes.
Thank you for your talk. I found it quite fascinating. And one reason is because I'm a co-chair of the Technical Oversight Board for the Industrial Ontology Foundry. So
Okay.
Whereas you are taking a sort of a bottom-up approach, we're taking a top-down approach, but we're also trying to simultaneously integrate enough of that bottom knowledge so that we provide some useful artifacts for people, for instance, yourself. So there are two items, two questions I have, at least starting with. First, you talked about the manual annotation. And I actually worked with a project to do that. And my question, did you give any, in terms of the UI you showed us, was there any a priori knowledge or information about the possible annotations built in there, you know, suggestions? Because in one of your later slides, you showed a list of things like manufacturing processes or stuff like that. Did that annotation process include any such, you know, prompts or anything like that?
No. So the way we were doing it is we simply took the index keywords in a couple of manufacturing textbooks, four or five textbooks. We gathered all of those manufacturing keywords, and then we are getting the user to tag, okay, If it's a machining process, would you classify that as a material, or is it titanium? Let's say, is it a material? What is it? And those categories it's something that we came up with. I don't know if it's comprehensive, but it's also, as best as possible, we're also trying to link it back to concepts that are there on Wikidata. So for every one of those annotations, you're asking the user to go and find a Wikidata item for the either that word, for mostly the word, and or a related word that you can think of that will go in. So that's how we're doing it right now. But there is no prompts right there. We just look at that word based on your knowledge. How would you classify that across the 12 categories?
Okay.
A better way to do it.
My next question, during your discussion, you said that you had a list of manufacturing processes.
List of
Well, in particular, you make reference to it when you were showing us that
oh yeah
graph,
right? Example that the graphs, and I showed a list of manufacturing processes, the thermoforming and all that.
Right.
Yes. So I went to so what we have done there is we went to Wikipedia, looked at the basic 7 or 8 manufacturing processes, each manufacturing process broken down to sub-manufacturing process. We took all of those keywords and then tried to find those related keywords from the raw data text that you have within the service, the content that is provided by the websites of companies. So that's how we did this. So those words came from the Wikipedia articles and the sub-manufacturing processes for each of those major categories.
Well, my question is, can we get a copy of that list of those processes and sub-processes that you great, because that would help the IOF in trying to understand the various domains we need to address, and more explicitly give us, if you like, use cases in terms of the ontological analysis that we're performing.
Okay. Yeah.
Well, thank you very much.
All of these data sets, even the human annotated, we're going to make that released out very soon once we complete that process. Both the tagging of the 3D model data sets from the 3D model to the manufacturing process, and then we're going to make that available, and also the tagging of whatever we're doing currently on the Google Sheet, that all of 4 or 5 students are collaboratively just tagging all of that. So we'll also make that available. So then that could then create, hopefully then run models that could then be used to do that. Yeah.
Excellent. Thank you very much.
Okay, Robbie has his hand up. Can you unmute, Robbie?
Can you hear me now?
Yes, I can hear you.
Hello?
Yes, Robbie?
I'll proceed. I'm just first wanting to know what is the end state you are envisioning when you reach some version 1 of the product or solution that you have in mind. Would people be going in for these automated 3D services to get new versions of products or improvements in their existing lines, etc., using OKN?
So one use case and that we want to directly drive out of this is, and we're working with GraphCAD on this. So GraphCAD says, and Onshape, both companies are wanting to interface tools on their platform so that users can find related parts, related assemblies, and functional categories, and depending on how they want to search it, they are willing to put out a beta testing tool. So that's one thing. Having the ability for users on GraphCAD and Onshape to find similar products so that they don't have to spend the time trying to recreate something that already someone has done and made available to share. So that's one use case that we will try to immediately show as a version. With actually the first 1 year, all of the code is available. We just have to process all of the models that we have. So that's one, finding similar parts, functional related and similar looking parts within GraphCAD or Onshape. The second that we really want as a use case is that you saw that portal in there. I want that portal is going to be released within the next 1 year, provided we get phase 2. But even if you don't get phase 2, I'll try to release what version we have right now, and build queries that you can search for. Give me flow forming manufacturing in who does flow forming in the US. If you search that on Google, you're not going to find that. So if I can create that portal, and flow forming is a search term along with any filter categories that I can find, or even related keywords that are related to flow forming, which would be either precision fabrication or precision foundry, and or a related aerospace category. So that would be on that portal as my second output that I'd like to see out of this process. And then you can filter it, dice and cut it in ways that the user would want. And we, as a feedback, would be once we have released that portal, what we are hoping is we get to see what those keywords and what those search terms are, and then seeing if our knowledge graph or our graph is actually configured to even deliver that query. And do we have missing data, or do we have missing data sets? So that hopefully would then drive further development of the knowledge graph.
To me, it looks like you would need third-party verification or validation services, similar to what one-time NIST provided to the automotive manufacturing industry, to test if the end-to-end package that a supplier agrees to execute from a customer is validated in the right knowledge and acceptable format for it to give a product or a finished service that you are after using this.
Right. For me, that would be a second stage. So right now the portal is just simply configured to do search and discovery. So if I can provide the user 3 or 4 companies that they're looking for a particular service, then that would, our job would be finished, completed there. But then the next step, as you said, is very true in terms of verification, validation. Did that company actually provide that service, or is it some service that they claim they have, but they actually did not have that? Or at one point they had it, but did not have it as of now. That, yes, is an important step in terms of refining back and making sure that how confident are we from a node edge between, let's say, flow forming and a company that provides it. How confident are we that a company provides that edge? And that probably has to be done through human validation. I don't have an answer on how we would do that. I'm thinking that this would be driven by, it's almost like some feedback mechanism that would go in to show it, or even looking historical record transactions that a company may have had in the past to sort of see how confident is this claim that this company can do 7-axis CNC machining. Can it really do 7-axis CNC machining as opposed to just relying on words on a key on a manufacturing website?
And last part, thank you. But last part is, how do you dynamically update information on your portal? Because some manufacturer whom you have relied on and rated in some way to present their capabilities have suddenly changed that capability for better or worse.
Better or worse, yeah. Very true, and that is why I showed that slide where we the web crawlers would automatically go to the website and get content information, but it still would require the manufacturers to update that tags or update that capability on their own website. And we talked to a manufacturer who said exactly this. They recently bought a laser cutter, but they just didn't get the time to update that on their website. So I asked them, look, if you're not going to website, Google would not know what you're doing. Service directories are not good at doing it. So we are still relying on these manufacturers to update the content, not even the website, not even the human readable HTML content, but rather the meta properties that will be embedded as on the website, each individual page of the website, or just even the home page of it. Yes, as of now, we're going to rely on them updating it, and we are tracking this. We could potentially track this by, just like Google does, on a last updated feature. So if there is last updated where it's been like years since they have updated that, then that would probably reduce the confidence of what they do provide. And I think we would also, going back to what services capability, not just relying on text that they have, but also relying on other pieces of information, such as a Facebook entry or a LinkedIn article or a manufacturing magazine that they, or the blogs that they may have had, or images that they've posted to lend confidence as to the capability that they're claiming that they have. That would be an interesting piece of research that we want to do in phase 2, and how can we verify the capabilities of what this company provides and not just rely on a single piece of information sitting on there. But yes, thank you for that. I think it is very pertinent.
Okay,
Thank
David,
you so
Eddie, and then Corey. So David, you have a hand up. David?
I think he's muted.
Sorry,
There you go.
Binil, do the keywords have definitions?
Yes, whatever definitions that, when you say keywords, which keywords? The manufacturing processes or the keywords? Did you mean
it was a deliberately ambiguous question. You put the word keyword on the table.
Keyword on the table, let me see.
You mentioned keywords. And surely you're not meaning HTML keywords, Google keywords.
Let's see.
Manufacturing terminology is both intentionally and unintentionally incredibly ambiguous. So I've never looked it up, but I should. How many different definitions of screw are there? I would assume hundreds. So,
so what we are, when we say, if you're going to embed particular service capabilities on a manufacturing website, or how do we tag this? If you saw the way that we are tagging it, we are still linking it back to the Wikidata entry for that specific URI on whatever that definition of that screw is, or definition of machining is. So we are linking it back to a description of that keyword, let's say, on a Wikidata entry, assuming that the Wikidata entry is also correct.
okay, big assumption.
Yes, big assumption.
Now, I'm by no means expert in the full range of capabilities of URIs. Rightly or wrongly, it's embedded in my mind that a URI points to one and only one thing.
Yes, it is.
Okay, that's obviously completely unacceptable. Anyway.
So yeah, so a one and only one thing. So it's trying to my understanding was that one and one only thing was to ensure that even if there was a different meaning of that word, then that would be a different URI for a similar meaning of that word.
I'm thinking more of, particularly in the context of Wikipedia, one of the really good things is the disambiguation pages.
Yes, yeah.
In that, oh my goodness, there are multiple contextual meanings for this thing, be it a person's name. It's always fun to Google your own name. So, oh my God, there are hundreds of them.
Yep.
And so that some mechanism to allow for multiple meanings for dumb strings of characters.
Yeah.
And I believe that's, someone else, comment or not, my belief is that that is not a function of URIs. Unique resource indicator.
Yeah, it is just a unique resource identifier. So the word, I think like Ford, right? Ford there's a URI for Ford as a president and Ford as a company.
And how about URI as a river crossing? How about a Ford for a river crossing?
Yeah, Ford for a river crossing. Yeah, so I think to my understanding is that each of them would have unique identifiers for each of them, referring to a president, referring to a river, or referring to.
I'm certainly enjoying watching your eyeballs go up in the top of your head. Does the necessity, the requirement for multiple meanings, easily accessible definitions, contextual definitions, has that been part of your thinking yet? It sounds.
Not yet. No.
Okay.
Not yet. Yeah.
Okay.
But it is, and that is one of the questions that we were raising. Hey, is there what terms in manufacturing do? And I think that I'm sure it exists. Is there where we'd have multiple meanings for particular keywords that you would have it. And I was just looking at the keywords that we have. Are there multiple meanings for the same index keyword, and what exactly does it refer to?
As a hint, since unfortunately I've been fascinated with this challenge, I did a little dictionary in 2006 and froze it. There were, at that point, there were 298 meanings for CC. So cubic centimeters, if you're making engines, you're going to have CC as one of your keywords. And last time I looked, it's a moving target. The last time I looked, there were 450 plus meanings. So run that through your calculator.
Right, yeah.
But anyway,
so,
okay.
So let's say a word like CC, and then a human user comes in and tags that as unit, and then refers to unit to a Wikidata entry for unit. And now when the word CC or anything referred to units appear somewhere in this concept, the whole point is that the model would not just recognize CC, but MM and CM and anything else that may be coming in the context of words used, so that that also gets auto-classified as a unit. I don't know if that would solve the challenge, but no, that's how we were approaching it. But yeah, I'm sure once we analyze all of the abstracts and raw articles that we're going to run into this problem. Yeah.
Anyway,
Okay.
I'm glad I ruined your day.
That's exactly what I'm looking to, like, because I would rather hear it now than put to 2 years later.
Okay, Corey's been patiently waiting with his hand up.
Good afternoon. This is Corey Castnave. Two related questions. One is, are there other graphs that you would see the graph you're creating integrate with? And secondly, are you using or publishing any common ontologies that you would expect to enable that integration?
One, yes, we're trying to, again, part of the CXL program is to make sure that whatever knowledge graph that our team is trying to build, that we find other graphs that you can connect yourself into. So the USC, University of Southern California, and University of Maryland, they're trying to build a business OKN, in which they are going about sort of doing similar processes, I suppose, but analyzing all of the import and export of products going into and out of the US, analyzing patents and analyzing all of the contents that is done by companies, not necessarily focused on manufacturing, but manufacturing is a key economic sector. So they are looking at manufacturing, looking at finance, mostly finance, but also related to manufacturing because we are supposed to link to each other. They're now going to also look at certifications, regulation policies, because that was really their initial focus, was to look at financial regulations, government regulations, any standards, anything that they would have to look at. So yes, we are trying to link it to the business OKN that group would be developing. As opposed to an ontology that would grow in terms of integration, yes, I mean, that's really what phase 2 should be about. Is how would we get that integration to be working? If you have ideas on how best to do that, I'm open to listening on how we could do that the best way. If there are references on how we could do that appropriately and correctly, and I'll be happy to hear and see how that would be done correctly.
Well, one I know that comes to mind is the GLEAF Foundation, Global Legal Entity Identifier Foundation, that has identifiers for most of the organizations in the world. If you look at gleaf.org.
Yeah, so we can link it back to a lot of the organizations, yes. Okay.
Obviously not manufacturing oriented, but
yes, yeah.
Actually it's more finance oriented, but certainly has the.
I know, I think I heard the business OKN referred back to that, so I'm sure they are linking it, they're probably linking it to that particular
yeah. It's worth also looking at GS1, who have a place identifier that extends to organizations and departments and things that covers a lot of manufacturing stuff.
Right, yeah, okay.
I pass the baton.
Mark Underwood. Mark?
Hey guys, just a practitioner comment regarding schema.org. Speaking of somebody who's built a lot of small business websites, really most of these people are using WordPress. That's about 30% of all the websites that are up from businesses. So you really want to use schema.org and have a WordPress plugin that promotes their ability to populate that with whatever the platform is that you want to, provide them with. So that's one thing. But I also was going to mention though that the product data is often not spiderable. So you have to address this from the other end of this, which is how the models are getting built and to inherit some of the metadata, the components in the build process, because those things end up inside a software artifact that has to be played out somehow in the website for the public version of the models. So I think you have to tackle that, because otherwise the public facing side of a website is not going to expose the metadata that you'd like to see there.
So yes, yeah. So in terms of the first question, yes, I mean, a lot of manufacturers, they either use WordPress or Wix or Weebly, one of those three, but really the top, WordPress being the one. And some of them have the free Yoast Pub plugin that allows them to embed that schema graph.
Right.
And I think, yes, I mean, a plugin of that nature would be the best way to sort of get them to use it appropriately. Certainly that in there. The second one, so are you referring to, okay, not just saying that this is a CNC machining or something, but more than that in terms of the actual process steps that they typically go about doing that they would actually then embed?
Well, there's several facets to this longer conversation probably, but the gist of it is that there aren't static web pages that exist for each of the models. The web pages are delivered based on queries produced by these intelligent URLs based on what the visitor is trying to find. And what is going to be exposed by those URLs is actually constructed by third-party tools that are composable services to build the models.
Yeah.
So that's what's being played back into the web pages. So if you can tackle it from that end of the problem, then you're kind of attaching yourself to the canonical practices that are happening on the build end of the models as well.
Okay. Makes sense.
Just practitioner thought.
Sure, I mean, trying to get that, because it's going to be a combination of not going after fancy techniques, but something that is practical, something that is cost effective as well, is trying to get that done. Yeah.
Right, agreed, thank you.
Thank you.
Okay, John Sawa. John, you have your hand up. Could you unmute?
I was just putting some references in the chat about some slides that I'm preparing for a talk about relating knowledge graphs to anything and everything by going through CLIP and DOL. DOL is the OMG standard, which relates the semantic web notations and UML diagrams and many other kinds of logics to common logic. So that common logic is the ground level logic that is related by all of the above. But common logic, people have complained that it's not really very readable. And so what I've been designing is a dialect, what I call CLIP, which is designed so that it's anybody who knows predicate calculus can read it immediately, but it has subsets that are for RDF and OWL that are as easy to read as Turtle. And it also has the subsets for larger kinds of things so that you can take any UML diagrams and you can use them for software design, and that gets mapped into the common dialect of CLIP. So CLIP is really the dialect that the system uses for talking at the level that people who understand semantic web and all that use. Now, one of the things that also is a question about URIs and those things, and the point I was making is that those are for system programmers. Nobody today who uses the internet ever gets down to TCP/IP, and URIs that are a level above TCP/IP. But I think that that's also the kind of thing that should be pushed down to a level that only system programmers really deal with, and that people should be able to talk to computers or type to computers in logics that don't have to use those fully disambiguated names, that rather the names can be disambiguated through context the way people do in a conversation with any other human being, that if you find a confusion, you ask follow-on questions until you get down to the point where you have resolved the names that you use for your discussion, and then underneath the covers, you're using things like the OED, the Oxford English Dictionary, for resolving lots and lots of names, and then you're using whatever other kinds of facilities for resolving URIs. But those URIs are going to be the kind of things that are as weird for normal people as the OED. I mean, the OED is this huge dictionary, and very few people use that for trying to resolve what they're doing, and they should never have to worry about URIs. And the languages that they use for communicating with the semantic web should not have to have URIs in them. They should be able to use local synonyms, local terms, which the system will resolve to URIs through a dialogue.
Yes, that's right. That's right. I mean, as much as possible, what we're trying to do in that portal is, the URIs again is just at the back end of what we are seeing. As much as possible, we want that portal to have simple, common queries that you would normally put in any search tool, search engine tool, and then the system resolve what exactly is the context of what this person is trying to search for. Yeah, point well noted. I mean, I think, thank you for the references and the Clint. I think it's something that I have to look into.
Okay, and one other point that I was making is that the whole idea of standardizing top-level ontologies is hopelessly misguided. Mm-hmm. That there's the TLOs are designed for silos. There's the silo that people who know BFO happen to live in. Then there's a silo for Dolce and a silo for Psych. Actually, Psych is the biggest group, and they have done some really outstanding work for resolving multiple silos. That they have the idea of microtheories, and the whole ontology is organized as a hierarchy of microtheories, so that you can have microtheories specialized for any topic you want. Whether you're, and for medicine, for example, you don't want a single domain, because there's the nurse, the nurses, the general practitioners, and the specialists in every branch, and the pharmacists, and the people who maintain the hospital, and the administrators. They're all dealing with medicine, but every one of them has a different set of interests and a different set of terminology that they're using, and they all have to communicate with any patient who walks in from anywhere who may have any kind of misguided information about anything, and they all have to intercommunicate, and they do that by ordinary language, and the ontology cannot be expected to enforce a single terminology for everybody. I mean, that's as hopelessly misguided as enforcing a single IRI or URI for everyone. So you have to be able to deal with an open-ended family of contexts and have systems that can automatically navigate around to find whatever context you are discussing it about.
So yeah, so it's not linking it back to a particular area, but then find the context around what is being described, and then figure out which URIs make sense to sort of refer back to it, right? Okay.
Okay.
Great. Well, we've run a little bit over, but I think we had a great discussion.
Thank you.
I want to thank everyone, especially Binil, for a wonderful presentation, and thanks to all the participants. And so I will now